Hi, I am Zaddy from the University of the Philippines in Los Baños. Our topic for today is about exotic species. But before we jump right into it, we asked some UP students passing by a while ago about their ideas regarding exotic species. And here are their answers.
Exotic species is kakaibang species.
Exotic species ay species ng hayop or halaman or even hayop or halaman na hindi mo mahanap sa country natin. Parang sa ibang bansa.
Either fauna or flora na hindi masyadong common para sa atin. So, madalas sila yung mga hindi natin talaga alam kung ano sila.
Rare po sila, hindi po sila common and hindi sila talaga kita everywhere na po. Exotic species yung mga species na hindi sa isang
Sounds like we could use a lecture here. Well, join me as we dive deep into the world of exotic species. The contents of this video are based on the study by D. Minchin, published as an article in the journal Encyclopedia of Ocean Sciences. So, what are exotic species? Exotic species are often referred to as alien, non-native, non-indigenous, or introduced species. They are those that occur in areas outside of their natural geographic range. Often confused with exotic species are vagrant species, which are those that appear from time to time beyond their normal range. Since marine science evolved following periods of human exploration and worldwide trade, there are species that may have become introduced at an early time but cannot clearly be ascribed as native or exotic. These are known as cryptogenic species. It is important to gain knowledge about exotic species because its introduction to a new ecosystem can result in habitat modifications that may reduce native species abundance and restructure communities. When an exotic species enters and survives in a new ecosystem, having lots of prey but no predator to control its reproduction, they turn into what we call invasive species. Traveling back in time, species have been moved for several hundreds of years, and some have almost certainly been carried with the earliest human expeditions. Evidence for early movement is scant. This can normally be determined only from hard remains, from a well-understood biogeography of a taxonomic group, or perhaps from genetic comparisons. An example is the transfer of soft-shelled clam Maya arenaria in northern Europe from North America linked to the Vikings expedition. It became sufficiently abundant in the Baltic to be referred to by quaternary geologists as Maya Sea. Another is the South American coral Oculina patagonica, established in southern Europe, was most probably introduced on sailing ship hulls returning from South America during the 16th or 17th centuries. Indeed, these sailing vessels probably carried a wide range of organisms attached to their hulls. Following the development of steam train is the transport from the eastern coast of North America of the striped bass Morone saxatilis fingerlings to California in the 1880s. So what are the vectors of exotic species? Exotic species are introduced either deliberately or inadvertently. In literature, inoculations are classified as either primary or secondary. A primary inoculation is where the first population of an exotic becomes established in a new biogeographic region. A secondary inoculation arises by means of further established populations from the first population to other nearby regions by a wide range of activities, and so the risk of spread is increased. The principal vectors are aquaculture, shipping, aquarium species, and trade agreements and guaranteed product production. In aquaculture vector, useful species are those that have a high tolerance of handling, can endure a wide range of physical conditions, and therefore are easily induced to reproduce and have high survival throughout their production phase. Mollusks such as clams, like Cruditapes filipinarum and Mercenaria mercenaria, scallops, like Patinopecten yesuensis and Argopecten irradians, oysters, like Ostrea edulis and Crassostrea gigas, and abalone, like Haliotis discus hanai and Haliotis rufescens, have been introduced for culture. For crustaceans, pinete shrimps are now being cultured worldwide. However, this has led to a series of unregulated movements resulting in serious declines of shrimp production caused by pathogenic viruses, bacteria, protozoa, and fungi. The aquarium species vector. Aquarium releases seldom become established in the sea, whereas in freshwater, this is common. The attractive green feather-like alga, Caulerpa taxifolia, was probably released into the Mediterranean Sea from an aquarium in Monaco, and by 2000 was present on the French Mediterranean coast, Italy, the Balearic Islands, and the Adriatic Sea. The shipping vector. Much of the world trade depends on maritime shipping. The scale and magnitude of these vessels are seldom appreciated. To travel safely, they must either carry cargo or water as ballast so that the vessel is correctly immersed to provide more responsive steerage by allowing better propulsion, rudder bite, and greater stability. Ships also have a large immersed surface area to which organisms attach. Nevertheless, despite the best efforts of management, ships carry a great diversity and large numbers of species throughout the world. Unfortunately, the risk of introducing further species increases because more ships are in transit and many travel faster than before and operate a wide trading network with new evolving commercial links. All studies to date point to a wide range of organisms surviving ballast transport, ranging from bacteria to adult fishes. Examples for ballast transported exotic species are the invasions of the cone jelly Nemiopsis leidii from the eastern coast of North America to the Black Sea. The trade agreements and guaranteed production function vector. Trade agreements do not normally take account of the biogeographical regions among trading partners, so introductions of unwanted species are almost inevitable. Often, a population of a harmful species is further spread by trading and thereby has the ability to compromise the production of useful species. Harvesting of cultured species may be prohibited in areas following the occurrence of toxin-producing phytoplankton. Toxins naturally occur in certain phytoplankton species, most usually dinoflagellates, and are filtered by the mollusk, and these become concentrated within molluscan tissues, with some organs storing greater amounts. Some of these toxins may subsequently accumulate within the tissues of molluscan-feeding crustaceans, such as crabs. The increasing emergence of unexplained events. Natural eruptions of endemic or introduced pathogens may be responsible for chronic mortalities or unwanted phenomena. The die-off of the sea urchin Diadema antillarum in the western Atlantic may be due to a virus. The unsightly fibropapillomae of the green turtle Chelonia midas, previously known only in the Atlantic Ocean, are now found in the Indo-Pacific where it was previously unknown. The great mortalities of pilchard Sardinops sagax neopilchardus of Australia in the 1990s and mortalities of the base scallop A. irradians in China may be a result of introduced microorganisms. Some areas favor exotic species with opportunities for establishment and so enable their subsequent spread to nearby regions. These are normally shipping ports within partly enclosed harbors with low tidal amplitudes and or with good water retention and a large number of arriving vessels. The dispersal of a species from its point of introduction and the speed at which it expands its range will depend on the behavior of its life history stages and hydrodynamic conditions in the recipient habitat. Biocontrol. Biological control is the release of an organism that will consume or attack a pest species, resulting in a population decrease to a level where it is no longer considered a pest. Although there are many effective examples of biological control in terrestrial systems, this has not been practiced in the marine environment using exotic species. However, biological control has been considered in a number of cases. The green alga C. taxifolia has become invasive in the Mediterranean following its likely release from an aquarium. The species presently ranges from the Adriatic Sea to the Balearic Islands and forms meadows over rock, gringos, and sands, displacing many local communities. The introduction of a Caribbean sacoglosan sea slug that does not have a planktonic stage and avidly feeds on this alga has been under consideration for release. These sea slugs were cultured in southern France, but their release to the wild has not been approved. The conch jelly M. lady became abundant in the Black Sea in the mid-1980s. It readily feeds on larval fishes and stocks of anchovy, and pilchard declined in concert with its expansion. The introduction of either cod Gadus morhua from the Baltic Sea or chum salmon on Chorhinchus gorbutia from North America was considered. The European green crab C- has been introduced to South Africa, Western Australia, and Tasmania, as well as to the Pacific and Atlantic coasts of North America. In Tasmania, it avidly feeds on shellfish in culture and on wild mollusks. Here, the introduction of the Josephalan saculina carcini, commonly found within the crab's home range and which reduces reproductive output in populations, was considered. However, because there was evidence that this parasite was not host-specific and may infect other crab species, the project did not proceed. The North Pacific sea star A. amirensis has become abundant in eastern Tasmania and may have been introduced there as a result of either ship's fouling or ballast water releases taken from Japan. This species feeds on a wide range of benthic organisms, including cultured shellfish. A Japanese ciliate or Typhophyra species that castrates its host was considered. Exotic species used in biocontrol need to be species-specific. Generally, predators, parasites, and diseases should be avoided. Shipping is seen as the most widespread means of disseminating species worldwide, and the IMO has held conventions that relate to improved management of ships' ballast water and sediments and hull fouling management. Aquaculture and the trade in living products also has been responsible for many species transmissions. To this end, ICES has developed a code of practice providing wise advice on deliberate movements of marine species that should be consulted. Species may be released in ignorance to the wild with potential consequences for native communities, such as what may have happened with the introduction of lionfish Pterois volitans to the western North Atlantic. The elimination of an impacting species can rarely be achieved unless found soon after arrival. Regular surveys as well as public participation and awareness may reveal an early arrival. The development of rapid assessment surveys for known target species may greatly reduce the duration of surveys and provide early information. Rapid dissemination of free access online journals such as Aquatic Invaders as well as regular scientific meetings, for example, the International Aquatic Invasive Species Conferences, greatly aid in distributing current knowledge. Programs such as the European Union's specialist projects assessing large-scale risks for biodiversity with tested methods, or ALARM, and delivery alien invasive species inventories for Europe, or DAISY, to map and manage invading species are likely to lead to new management advances in understanding vector processes and through the development of risk assessments. It is certain that further exotic species will spread and that some will have unpredictable consequences. I hope you learned something. Thank you.